Alright, probability involving OR, and the situation is here. If a single die is rolled, what is the probability of it being 2 or odd? Okay, let's think about our sample set for a second. In this case here, our sample set is small enough that it's not going to be too difficult for us to actually think about what's happening. So we're rolling one die. So our sample set, in this case here, is going to be 1, 2, 3, 4, 5, 6. So, the question is what is the probability of being 2 or being odd? Okay, so the thing is this. Here's my 2. There's my odds. Do they happen at the same time? No. So they're not mutually exclusive. If they're I'm sorry, they are mutually exclusive, excuse me, because they do not happen at the same time. They are mutually exclusive. Therefore, we can use this bottom equation. So in this case here, it's a much easier problem to set up because we don't have to take away that other piece. So as we start looking at this, what we see is these are mutually exclusive. Therefore, the probability of being a 2 or an odd is broken down into the two little pieces. We have the probability of being a 2, oops, wrong one, probability of being a 2, plus the probability of being an odd. The probability of being a 2 is 1 out of 6 because there's 1, 2 out of 6 possible combinations. Remember that we always work probability as what we call our favorable over our total, and that's outcomes. So in this case here, our favorable outcome was the 2, so that's 1 out of 6. The probability of being odd is 3 out of 6. And we take that, we add it together, we get 4 out of 6, and reduce that to 2/3. So the probability of being a 2 or an odd is 2 out of 3.